Okay, for question 6, we are required to design an ideal amp-up based amplifier to give a gain of positive 32 volts per volt while using the minimum number of components. So we have access to 1K and 10K resistor pins, and we also just a single op amp. Okay, so we need to draw the circuit and then what's the input impedance of the design amplifier. So one of the solutions that we can find out is that because we need like a positive 32 volt per volt gain, we can use a non-inverting amplifier, okay? And for this non-inverting amplifier, one way to get, if you remember the voltage transfer function, so first if we draw the circuit here, so we have a resistor here, goes there, and then we have another resistor here, goes to the output here, and then we can just plug in our input here. This is the non-inverting input, this is the inverting input. We can call this R2, we can call this R1. So we know that the voltage transfer function, so V out over Vi for this particular circuit, is equals to 1 plus R2 over R1. Okay, so that's the voltage transfer function. Now, because we need this number here to be equals to 32, one of the possible solutions is that if we set, so this is, just put it here, V out, this is Vi. So if we use R1 equals to 1K, so we are using just one resistor for R1, and then we can use R2 equals to 10K plus 10K plus 10K plus 1K, right? Or R2 equals to 31K ohms. So if we substitute, so this R here becomes like 3 resistor, right? So we can basically just erase this part here. This one here. In this circuit here, it becomes just a series of 4 resistors. Okay. So overall, the gain that we have, V out over Vi, is equals to 1 plus 31K divided by 1K, which is equals to the 32 volt per volt that we needed. And what's the input impedance of the designed amplifier? So if you remember again, the input impedance, so for part B, the input impedance is equals to the voltage, they'll call Vi, divided by I1. And I1 is this current here that's flowing in this direction, and this is the voltage Vi. Now if you remember, for an ideal amplifier, there's no current entering or leaving the non-inverting or inverting input ports, right? So this means that we, no matter what's the value of Vi here, right, unless it's 0, but then there's no amplification happening, this current here is 0. And this basically means that this tends to infinite. So the input impedance for this particular circuit, it approaches infinite. So it's a very high input impedance.